Carbon dioxide is what would come from dry ice. Still a very good guess. Steam is the right answer. Very good. So, where do you usually see steam? Anybody? What room in the house? The kitchen. And in the kitchen, there's a stove. You can heat up water. You didn't realize I had a stove built into this table, did you? Well, clearly, I don't have a stove built into this because otherwise my paper towels would be burning. And yet, wow, that's really hot. This got hot enough, and I can, if I'm careful, I can make like little steam rings. Like, I don't know, you probably don't watch Gandalf, but I can make little steam rings. This got so hot that all that steam came out of there. The easy answer is to think about who I am. How do you think I made that happen? What did I do? I did some, it's a big C word, chemistry, right? So in this particular case, I'm not a magician, so you want to know how I did it? I used two things. Anybody heard of hydrogen peroxide?
Yeah.
Okay. Now, what's different about this hydrogen peroxide, it was a lot more concentrated, but it's the same stuff that you would use to clean a wound at home. Last time somebody put hydrogen peroxide on your skin, did it get hot?
No.
I don't remember that happening either. If it's a lot more concentrated, you'll notice it heating up, but that's not something you'd ever want to put on your skin. The other thing, if you know, I don't know if some of the people in the front might have seen this, I dropped in a little bitty piece of paper. It had some powder in it. And anybody's parents always remind them to put the lid on the peroxide if they're using the peroxide. You know why they always tell you to put the lid on other than they don't want to mess? There's another good reason to put the lid on the hydrogen peroxide. If you leave the lid off, it's not flammable, but it's a very good guess though. It doesn't really smell too bad, but that's also a really good guess. Might react if something got into it. In fact, that's a really close answer. I'm going to go with that. Hydrogen peroxide, when it bubbles on your skin, you know what's inside the bubbles? Oxygen, same stuff that we want to breathe. And if you leave the lid off the hydrogen peroxide, eventually all of the oxygen, all of the hydrogen peroxide will break down. At this point, it doesn't look like water because it's not very clean, but all that's left is water and some of that stuff, some of that powder that I dropped in there to make it react really fast. So hydrogen peroxide is something that I like to use for some of my demos. Anybody seen this one before? Don't tell me what it is. You've seen this one? You think you know what I'm going to do with this? Anybody have a big pet? Who's got a big pet? What kind of pet do you have?
Elephant toothpaste.
What kind of dog?
Yeah.
A lab? He's like maybe like this big? No? Like this big? Anybody got a bigger pet than this? A Great Dane. Now that's a really big dog, isn't it? How about somebody with a pet bigger than a Great Dane?
A lab and a Great Pyrenees mix.
A lab?
A lab and a Great Pyrenees mix.
Lab and a Great Pyrenees mix. How big is that? I don't know that one. About pretty big? About, yeah? Something bigger than a big dog, maybe? Because we got to have a big pet for this to work here.
A horse.
A horse would be a big pet. You got a pet horse? Maybe you know somebody with a pet horse. Bigger than a pet horse? An elephant would be perfect. Who's got a pet elephant? Wonderful.
Liars.
Because this experiment is called, who knows the name of it? Elephant toothpaste. So what I want to know is, can you see anything happening? Is anything changing in there? Anything changing? Nothing? Anything changing? Nothing happening? Anything changing? No changes? There's some bubbles in there. There's some yellow color in there. But there's no changes. In fact, like she said, because I think she's seen this before, this really is changing. But I can't see it change. Can you think of something that you know is changing, but it's happening so slow that you can't really tell that it's changing? There could be heat coming from it, but think of like at home or in real life. What changes but happens so slowly you can't really see it happening? Rotation of the earth. It's tough to see this. It seems like this, and realize they say the sun is moving, but the sun's not moving. It's tough to see it look like even the sun is moving, isn't it? But we know that's changing. That's a good one. What else? You guys are growing?
Yeah.
I couldn't see that. I can't see you growing, but we know you're growing, right?
Yeah.
What else grows slow enough that we can't see it actively growing? What's outside your house? The grass and the flowers and the vegetables. What else? Here's one back here. Plants. All those plants are growing, right? Maybe animals. All of these things are growing. Now in science, if something's happening slowly and I want to speed it up, usually what I'll do is add a catalyst. Can you say that with me? 1, 2, 3. Catalyst. So we'll add a catalyst. This time my catalyst is potassium iodide, and it's this yellow solution. Anybody know what kind of fruit? It's another yellow thing. What kind of fruit has potassium in it? Bananas. But this isn't from a banana, and it doesn't smell like bananas, and etc. It's not a banana. But it does have a lot of the same stuff in it that's in bananas. And if I add this, I'll speed it up because this is a catalyst. So the reaction's already happening. All I'm going to do is speed it up. You ready? Give me a countdown. Go 5,
4, 3, 2, 1.
Was that faster? Craziness, right? That was already going on, but we couldn't see it. Do it again. Next time. We'll do it next time. Now, in this case, well, you'd miss all the other fun stuff I want to do if we did it all again.